Unit 1 covered GDP data. These are accounting facts. But knowing what happened is only half the battle. To predict what will happen, we need to move from accounting identities to behavioral equations. Unit 2 introduced the first pillar of our model, the IS curve. It stands for investment and saving. The focus here is the goods market. At its heart lies the search for equilibrium. This is the point where production perfectly matches demand. In a balanced market, there's no unplanned stockpiling. That means no goods are left gathering dust in a warehouse if they weren't meant to be there. The analysis starts with the private sector and the Keynesian consumption function. Spending is driven by two main components. First, there is C0. This is your autonomous consumption, or the basic spending you do regardless of your income level. Then, there is C1, the marginal propensity to consume. This measures how much your spending increases for every extra dollar of income you earn. This triggers the multiplier. A small spark in spending creates expanding waves of income through subsequent rounds of trade. One person's spending is another person's income. This income then fuels even more spending. But there's a catch, the paradox of thrift. If everyone tries to save more during a recession, total demand collapses because your spending equals my income. If everyone stops spending, an economic ice age begins. Individual common sense results in collective failure. Total savings remain unchanged, but the economy is ruined. To add realism, we bring the real interest rate, or R. We use the Fisher equation to separate the nominal bank rate from the real cost of time. This accounts for inflation. Firm-level decision depends on two main factors. First, there is A0. It represents the business confidence, which Keynes famously called animal spirits. Second, there is A1, the interest sensitivity. This measures how much higher borrowing costs actually force a firm to cancel a project. Combining this with the multiplier gives us the IS equation, y equals A minus AR. The curve is downward sloping because cheaper money stimulates more investment. Every point on this line represents a state of perfect balance. It is where the goods market clears. The final piece is the logic of time. It answers a fundamental question. Why do our decisions today depend so much on what we expect for tomorrow? Forward-looking behavior explains how we consume. Through consumption smoothing, we basically borrow from our future rich selves to feed our current student selves. We spread our lifetime income out to keep our lifestyle relatively stable. Firms apply similar logic with present value, or PV. Every investment is a bet on the future. When we compute V, it shows whether the stream of future profits justify the cost today. So while the IS equation itself looks static, its position is actually driven by these future-based decisions. Changes in these expectations are precisely what caused the entire curve to shift. This sets the pose of the demand side. But to truly grasp how this model moves the needle in the real world, there are three deeper layers of logic I want to explain. First, let's look at the hidden connection to the supply side. The IS curve is often labeled as the demand side of the model. However, its very existence depends on one crucial assumption. We assume that demand is always met quickly. Whenever you analyze a point on the IS curve or look at why it shifts, you are making an implicit assumption. You are assuming that firms can immediately absorb production factors and spin up their machinery to increase output. This means that every single coordinate on the IS line is a state of perfect balance. Supply and demand are identical. This logic is the absolute root of the multiplier effect. Think about where that extra value of income actually comes from. It happens because every dollar spent becomes income for a node in a massive social network. That income then triggers new demand. If that demand is met by production, it creates even more income. At its heart, the economy is just a massive system of human cooperation. It creates a network effect where the total result is much bigger than just the sum of its parts. This synergy, millions of people trading together, is the real reason the multiplier exists. But its power often depends on trust. Textbook might blame a low MPC, but the real problem starts when the social connection begins to fail. When people lose trust, they pull back and stop engaging with the system. The chain of trade breaks. The lack of participation, whether it's on purpose or not, is what actually drains the multiplier of its power. Second, to truly master the IS curve or any equilibrium curve, I think you should approach it through 4 specific logic dimensions. Start with axis. You must clearly identify what are the horizontal and vertical variables represent. This is not just about labels, it's about the boundary between two things. What the model explains internally, which are the endogenous variables, and what it takes as given from the outside, which are the exogenous variables. Next, focus on the equilibrium condition. This is your algebraic bridge to balance. You need to understand more than just the derivation. You need to understand the meaning of being on the curve versus being off it. What is the fundamental difference between a balanced point and a state of imbalance? And when a point moves along the curve, what specific economic logic is actually unfolding step by step? Third, identify the parameters. These are the character of the curve. They dictate the slope or sensitivity. They also determine exactly when the curve will rotate or when it will shift horizontally or vertically. Finally, you must confront the limitations. The textbook admits that aggregate demand is driven by many factors beyond current income. These include future expectations, credit constraints, and the real interest rate. The basic IS curve simplifies or leaves many of these out. If you are interested in theoretical exploration, you can try integrating these missing variables. See if you can arrive at your own some new economic conclusions. Third, and finally, we must address the foundation of all dynamic models, discounting and present value. These concepts are the architectural framework for every part of economics that touches the dimension of time. They are the core soul of modern finance. The math of present value looks simple, but its real power lies in its connections to other models and concepts. It measures value across time by pulling future profits into a single value for today. Understanding these linkages is the key to mastering intertemporal choice, the core logic of how our future expectations shape our present reality.